board, we see that there are 1, 2, 3, 4, 5 partition. Actually, this is a diagram. First one is for wall for device, another is for wall for channel, and then the seek time, and then the rotational delay, and the data transfer time. So, if we sum up wall for channel plus seek time plus rotational delay plus data transfer, the total time is known as the busy time of devices. That means in this time the disk is totally busy by the I/O call to the OS. Now there are so many algorithms in disk scheduling. For a single disk there will be a number of input-output requests. If requests are selected randomly, we will get the worst possible performance. Several algorithms exist to schedule the servicing of disk I/O requests. Now we will discuss different algorithms like FCFS, C-scan, S-scan using a numerical example. We have to calculate different kind of performance, means this movement. So see the board. Now consider the very easy and simplest algorithm known as FCFS. First come, first serve. This algorithm is very easy to implement, but this is not the optimal one. There are another algorithm which is optimal, but first we have to understand the FCFS. The problem given here is the different track number are given like 98, 183, 37, 122, 14, 124, 65, 67. And the platter contain total 200 track. That means 0 to 199 track are there. And currently the head is at the pointer 53, means track number 53. Now we have to visit all the tracks according to our queue. FCFS serves as, it first serves the first request, then it serves the second request. What we have to do? We have to find out the number of head movements. Actually, this efficiency depends on number of head movements. Now, very simple mechanism is, where we have now? We have now at 53. 53 is nearby 65, so we consider 53 is here. Now the disk A starts from this pointer to first request is 98. Then he have to move to 98. Then where the head have to go 183. Now the disk head is at track number 98, but it have to travel up to 183. Where is 183? So we draw another line up to 183. Now how we calculate the head movement? Actually head movement nothing but first time we are at 53 and go to 98. That means how many moves are there? 98 minus 53. Now we are at 98, then we have to move at 183. How many moves are there? 183 minus 98. Now where we have to go? We are at 183, but our queue shows that we have to move to 37. That means, where is 37? 37 is here. So we have to back to that pointer 37. How many moves are there? 183 to 37. Now, where we have to go? which is the tab number 122. Now again we have to move up to 180. So how many head movements required? One, we are here, that means we are 37, and we move to 122, that means 122 minus 37. Then from 122 to we have to move 14 because our Q represent, we have to go to 14. That means 122 minus 14. Then 14 to 124. Then 14 to 124. That means 124 minus 14. 124 to move 65. Where is 65? This point is 65. So we again move to 65. That means 124 to 65. And last Q is 67. Now where we have? We have at 65. So we have to move just to 67. How many moves? 67 minus 65. If we calculate these values and then sum up, we will get 640. That means total number of head movements using FCFS algorithm, total number of head movements is 64. Have you got this? We subtract this value from this, and the total value we get, if we sum up, we will get 640. Okay. Now we will discuss another algorithm using this example.